Hi, Tyler. Thank you for indulging me just for a moment.
Yes, ma'am.
Okay, so I'm gonna go ahead and start the sharing. I think by now you're probably familiar with how we do things in this class, but just to make sure that we're on the same path or on the same page. Uh, here we go. So I don't know if what I posted for announcements. Oh, I posted a project video, and that video kind of takes you through the writing of the summary and the scoring of the summary. Okay, since we're beyond talking about finding an article because that deadline was Saturday, gone. Now we can start talking about the writing of the summary and how it will be scored. So I put the video there as a kind of an introduction, right? And I will talk about the project, but I want to wait and talk about it next week when we have a little bit more time. So what'll happen is next Monday I'm going to cover the waves and simple harmonic motion experiments, and then that Wednesday I can talk about the project. Okay. And so, that'll be an additional explanation so that you know, we're making sure that what you understood, what you saw in the video, so on and so forth. And you have an opportunity to ask me questions about the project. But I want to wait and do that next week. Okay. Um, that is because your focus on these three overviews for this week, right? I will say this that this work and energy experiment is pretty involved, so it's probably best that I wait and discuss the project then anyway, so that you can focus on these experiments. The momentum experiment is pretty straightforward. You got the experiment handout. You go out to the website, okay, open up the simulator, and then you're going to use that simulator to address any questions that fill in the table, answer any questions that they ask you. Uh, I had a student email me saying they couldn't figure out how to make it elastic or inelastic, but you can see right here there's a slider. Okay, the all the way over here means it's a perfectly elastic collision. All the way over here means it's perfectly inelastic collision. All right? That makes sense to you?
Yes, ma'am.
Okay. And then, there is a collision where it is um, total, you can control whether it's they stick together or something like that. The idea here is that when you're dealing with the inelastic collision, as I mentioned today in lecture, kinetic energy is not going to be conserved. So again, you just follow whatever settings they ask you to utilize, and then answer the questions that they ask. Um, so I think for this material, you will most likely be using the intro setting. That's because these are two-dimensional. I don't, I don't, we don't even cover that in lecture class. So just focus on the intro setting or the one-dimensional setting. All right. And then after that, the basic idea is do your lab report, do your post lab discussion. Don't forget to post your answer to at least one of these questions today. Um, I noticed in your response to one of them from last week, it wasn't too readily apparent which question you're answering. So just you mentioned something about merging things, and I saw where you did it on one. but I don't remember even if you went back and completed the other one. So just help me out there a little bit. Whatever question you're answering, put that question in your posting so that I know, oh, this is the question he's already answered. These are the ones that have to be answered. Okay.
Yes, ma'am.
All right. That helps me out. Keep things straight in terms of your actual grade. Because I'll be honest, you're about the only student that's showing up, and so um, well, I don't know. Maybe you're not in contact with the other students to tell them, hey, you probably need to start going to lab class because you're losing points.
No, I don't have any other contact information. So
Yeah. So okay. So the other experiment that relates to the lecture that I had today was work and energy. I started that. I'm not quite done with it yet. This experiment is a little bit more involved. Okay. Now, don't worry about when you go into the actual experiment and the simulator, they talk about Edmodo and Logger Pro. That's why I bolded it here. You don't have to worry about that. Okay. Edmodo and Logger Pro is like if you're doing handheld calculators, those fancy calculators, if you're using one of those, but we are not. So don't worry about it. Okay. So you can open up the handout, and then right below it, I gave you the link that you need to go to. And that's because they've updated they've been doing a lot of work to update their experiments to work in the browser. And I just hadn't had a chance to get in the document and put the corrected link, at least to my recollection. I don't think I did. Let's see. Maybe I did. I don't know. Let's see if I did or not. Yeah, I actually did. Okay, but either way, it's there. It's not a major thing there. But so once you go in, they tell you what settings to use. You will need a timer on this one. Okay, so like your stopwatch on your cell phone or if you have a stopwatch on a wristwatch, a simple timer will do. And that is because on this simulation you have to be monitoring the time because you need it to do some calculations. Okay, so the way this one works is you take the skater and you put them on the track, and then I'll turn on some of the things here while they're moving around. See, when you turn on all these buttons, you have the height being measured in meters, and you see it's keeping track of the energy for you. Okay, so notice in this particular setting, on the intro setting, there is no thermal energy because there's no friction. Okay, and so basically this skater would go on and on forever, conceivably. um, what you have to be able to do is you have to be able to pause the skater, measure the height and the speed, and then utilize that to do some calculation. So now let me stop them. Let me take the skater off the track completely, put them back on now. So you see we're starting the skater on the left side. When you pause it, you want the skater to be back on the left side. So don't pause it while the skater is on the right side. Always let them make a return trip and then pause it. And what you're going to be doing is pausing them at, different heights according to what they tell you in the experiment handout. I believe it's at uh, 6 meters, then 4 meters, then 2 meters, then zero. And you got to practice it because, you know, you want to have some dexterity and pausing the timer and the skater and the simulator, you know, at the same time. So that's why it takes a little bit practice. I always tell students, if you have somebody, it could be a household member that's willing to help you to do this one, is pretty good. It is good to have one person on a timer, one person on a simulator, so that you can kind of coordinate and pause and then pause and then pause, you know. So you got to be able to be comfortable with working the timer and the simulator. Okay. So just you're going to use the simulator to complete the table. You see here, they explain to you how to read the values on the timer in this visual. Okay. So that you know how, notice on the simulator, there are no numbers on this speed dial here, but in the handout, they tell you how to interpret the speed dial. And then here they tell you how to interpret the mass um, slider. So in the middle is the 10 kilograms that you want. Okay. And then you're recording the time, the height, and the velocity. They say speed, but for us that kind of you know, means the same thing, because technically when you do the calculations here to calculate the time, the potential energy, kinetic energy, and total energy, I helped you out there. You see right here, help with energy calculations. You see that document there on the screen? I'm pointing to it.
Yes, ma'am.
If you open that document, it explains to you how to calculate the kinetic energy, the potential energy, and the total energy. Okay? So that's part one. You calculate those values, you
Um,
fill
with potential energy, what it says P equals, and what is that? M88?
mg.
Yeah.
I'm
Mg. All
sorry.
right.
Yeah. I apologize for my chicken scratch. I should probably at some point go back and type this document to be helpful. But
Okay,
yeah,
I'm sure you my handwriting's way worse.
okay. So M times G times H. Okay. And then to get the total energy, just add them together. So at, you know, for each, notice that for each time, which is coming from the timer, you have to calculate those values and fill in the table. Okay. And then in step 7 below that, you're going to make a graph. Okay. I don't have an instructional video on how to graph, because you should know how to make a graph. You're going to make one graph and you're going to have T with each one of these. So T with potential energy, T with kinetic energy, and T with total energy. So on that one graph, you'll have a line, a plot for potential energy, a line or a plot for kinetic energy, a line or a plot for total energy. When I'm saying the word line, I don't mean it's linear. I just mean that whatever you graph, okay? And so I always tell students on this one, it'd be a good idea, like if you use some different markings for each one of these so you can distinguish potential energy, kinetic energy, and total energy from each other. All right. So, you know, just like they're using green for kinetic, blue for potential, and whatever that is for total, you might consider using some different colors to make each one of these lines on that one single graph. Okay. Do you follow what I'm saying there?
Yes, ma'am.
Okay. And then you're going to go to where they ask you to deal with the non-conservative forces. Let's see, part 2. And so that's done by utilizing the friction tab. Okay. And so we'll turn on all of the okay, bells and whistles here. And same idea. Okay. You got, well, gonna put the skater on the track and let them go. And you want to measure them when they come back to the left side. Pause it when it come back to the left side. But you notice something happening here. The skater started off way up here, and unlike on the other track, they don't come back to the same height. That is because now you see you have thermal energy in the mix. Thermal energy is just a fancy word for friction. Energy lost due to friction we call thermal energy. Okay, so you are not going to be able to fill in the entire table on this one. Okay, you're not going to be able to fill in the entire table because the skater is not going to go for a full, they say, I think 45 seconds to a minute or something like that. Oh, I'm missing that. I skipped over the data table, my bad. So here, you see they say for 45 seconds, the skater's gonna stop before 45 seconds. You aren't gonna be able to time it for 45 seconds. So you just get as many values as you can, okay? Again, you won't be able to have them go for 45 seconds because you can see here, if I let the skater go, in a matter of a few seconds, they've pretty much lost all the energy that they had at the start. Okay, and you can see as they lose energy from the kinetic and potential sides, the thermal energy keeps getting bigger and bigger. So eventually they just stop because they've lost all the energy due to friction. Okay, and so you won't be able to go for 45 seconds, but get as many readings as you can. And then you're going to use that in this table here to calculate the potential, kinetic, thermal, and total. And I help you out with that as well, because in that document with my poor handwriting, I have a part 2. So the kinetic energy is the same way, potential energy is the same way, but you have this new category, thermal energy. Okay. And so to get the thermal energy, okay, at any height, the total energy equals kinetic plus potential plus thermal. So the thermal energy, I just did an algebra thing, means to take the total energy minus the kinetic plus the potential. Well, the question then is, what is the total energy? Well, the total energy is what you would have when you're at 6 meters. To find the total energy, you have to plug in 6 meters into mass times gravity times height, which is easy, right? The height is 6 meters, gravity is 9.8, and the mass of the skater is 10. So that tells you the total energy. In other words, what's the most energy that the skater would ever have? And that's your total energy. And then so that's what gets plugged in here every time. Every time you want to calculate thermal energy, because remember, you have to fill in the table, right? You have to fill in this table for as many values as you measure. And then that's how you get the thermal energy in each case, by taking the total energy minus the kinetic plus the potential at that time. Does that make sense to you?
Yes, ma'am.
Okay. And then you're going to graph that. One graph, and then use different colors to, or different markings to distinguish one type of energy from the other. Okay. And then when you're finished all of that, then you're going to go do your lab report. All right. Typical format. And then post lab. So that means tonight you would have to post an answer to at least one question from each of these. I tell you what, yeah, from each of these. And I will look, if you post an answer to one question from the discussion for each of these by tomorrow, say tomorrow night or something like that, I'll look at it, as long as you don't post your answers to all of them on Saturday, right? The idea is that you're supposed to, because you're here, you're supposed to answer at least one of them. I tell you what, I mean, and I want to just be honest with you, because it seems like you're the only one that's coming to lab class on a consistent basis. For you, I'll just do away with that because I know you're here because you're the only one here, right?
Yes, ma'am.
So,
I
so
mean, I'm always gonna show up for the lab.
yeah, right. And so we can basically just dispense with that. That's an announcement that I put out there to get participation. Since you're the only one participating, you don't have to worry about it. But that's just between me and you, right? Because if on Wednesday we have 5 people show up, then I'm gonna tell them that you should have you should post your answer to at least one of the questions, right? So I guess if you want to, I could do what. Hi, Tyler. I'm sorry, my internet dropped off on me. Last week I was having trouble with it. It seems like whatever they did is not solving my issue because that's the second or third time it's happened to me today.
Yes, ma'am.
So I do apologize. So look,
That's fine.
let's just say this. I'll be here on Wednesday. If you have any questions that you want to ask me Wednesday, don't hesitate to drop by. But
Yes,
as
ma'am.
far as the actual experiments, I think you get the idea. This experiment on the states of matter, um, you're going to go to the website, you're going to use it to help you answer the questions, okay? And then do a lab report, right?
Yes, ma'am. Um, I've been doing all your assignments on Saturday. I think I'm gonna start doing them earlier because
Yeah, you
pretty much.
can. You're right. You should be, right? Look, my idea is that I give you until Saturday, but
Mhm.
that doesn't mean you have to wait until Saturday.
Well, I have classes 4 days a week, and I work a full time job, so it's a
Oh,
little
I'm
harder.
sorry.
But
Okay, I got you. I got you. I got you.
like, I usually have Fridays off. Like not
Yeah.
off. I have Fridays. I don't have class, so I'm
Okay.
gonna try to at least work on it then.
Yeah. Okay. So like for the states of matter, you go out to the website. Now, you don't have to do a lab report for the states of matter if you're looking at the screen here, right? You just have to do the handout.
Hmm.
Okay. So you got to do momentum. There is a lab report for momentum. Energy, there's a lab report for energy. States of matter, just the experiment handout. Okay. And since I pretty much covered the experiments with you, we can dispense with having class on Wednesday if that's convenient for you.
Yeah, I'll just email you if I have any questions.
That's fine. If you need to see me on Wednesday, just say, hey, look, I really need to have a few minutes with you during class time today. And I'll make a point of being here on Wednesday. I'm going to be here anyway, in the event somebody else shows up. I mean, it could happen, I don't know. I doubt it,
The
but
so with the homework, you and me just I don't have to
you don't have to
comment.
post early today if you don't want to.
What was that?
No, I'm saying, like I've been saying, post your answers to questions early.
Mm,
Like you don't have to do that because it's just you here.
this one.
That was designed to
Get
motivate folk to come to class. Well, you've proven that you're motivated, so just do your work before Saturday, and you're good.
this, man. Sounds good.
All right. So unless you have a question for me, we're pretty much done.
No, I can't think of anything right now.
All right. Take care, Tyler.
All right. See you later.
Bye now.